Okay, thanks Jens for the introduction. So I'm from Nokia. I'm leading the radio systems research of the network side. Okay. And I want to take you on a journey how we can optimize the spectrum usage for 2020. So that includes also LTE. And then also we'll try to give you a glimpse how we can look for spectrum for beyond 2020, which comes then into the conjunction with 5G. Before I go into the details, I have looked up a statement from the CEO from Vodafone. And Vittorio told that spectrum is the lifeblood of this industry. And that's true for the mobile communication. So we need to be really sure that we identify the right spectrum, that we optimize the usage, that we have at the end the right products in order to deploy networks and to make money out of it. So that always goes hand in hand, that whenever an operator does a spectrum strategy, he also needs to do that properly together with the network deployment strategy. Because the spectrum you utilize or you go for decides then how you deploy it. And as we all know, the mobile communication and the network start that you need to provide basic coverage. And here the spectrum below 1 gigahertz comes into the play, which is predominantly used by means of frequency division duplex, and where we have to deal with a rather limited amount of bandwidth which is available. Then later on, after we have played the coverage game, the capacity game comes in. So we are utilizing higher frequencies between 1.5 and 2.5 gigahertz, also predominantly used by frequency division duplex. But here we can now deal a bit with wider bandwidth, so for example 10 to 20 megahertz. And where we also see the first deployments of heterogeneous networks, which I call here light headnets. And then what we will see as a next step, already starting, is that we also have the densification further with frequency bands which are going from 2.5 up to 3.5, where then also the TDD technologies comes into the play. And last but not least, we also have complementary approaches. Like I will touch briefly on the license shared access, which could open up the 2.3 gigahertz band in Europe. And we have the 3.5 gigahertz, where we have heard already about the model which is discussed in the US, where we also have opportunities to apply LSA or to apply about co-primary sharing. And last but not least, I will also briefly touch on how we utilize and how we need to use the unlicensed spectrum for the benefits of us as a whole industry. Overall, it's clear we don't have infinite resources, so we have a limited amount of spectrum. We can't generate new spectrum, so we need to optimize it. Pierre already mentioned that we have rather complex regulatory processes. And what is the root cause for that? And this possibly also sparks the discussion, can we optimize that? And can we make regulation a bit simpler? So all the attractive spectrum which is currently used is assigned to some service today. So what we would need to do if we want to get access to this new type of spectrum, we need to repurpose that spectrum. That means reallocating existing services. And one of the best examples was the transition from analog transmission for television to digital. So that was the digital dividend, where we had been repurposing the band then for mobile broadband use. The next thing what is important for the spectrum is that we do harmonization, and that spans countries and regions. And this is a rather lengthy and complex and painful process, because you need to find agreements what the nations or what the countries are bringing into, for example, the CEPT level, and then what the regions are preparing. And then always 4 to 5 years in a row, the World Radio Conferences are being held where all the regions are bringing their views together in order to formulate how the spectrum will be allocated and used. So the preparation for the World Radio Conference 15 is already underway, but you always have long cycles what you need to prepare in order to steer something in. And after the World Radio Conferences have reached an agreement, then you need to go back again and you need to mirror it on the regional and national level. For example, just recently the CEPT raised a license statement towards ETSI and the 3GPP on the band plan for the 700 megahertz, which is a preferential outcome of this 2 times 30 megahertz. And then you need to implement it. That means that countries need to assign the spectrum for that purpose, which is, for example, happening on the 700 megahertz pretty soon in Finland and in Sweden. So this is a rather complex process, but it has been proven successful. We can argue later on in the panel, do we need to change something, for example, for systems beyond 2020? What are the advantages and what are the possible disadvantages? So I told you that I will not directly jump into 5G, because I will also tell you what innovation already is ongoing to optimize the spectrum for bands below 6 gigahertz. And predominantly here, we see this carrier aggregation because we have a patchwork of spectrum where we have now the technology introduced with the LTE Advanced, how we can aggregate the spectrum and the fragments. So this is where you, for example, know in Korea, it's the first country deploying carrier aggregation with 2 times 10 megahertz. They are pretty soon moving also to 3-band carrier aggregation. And we have seen already in one of the charts today that there is a huge number of band combinations specified, which makes the implementation pretty difficult. The second thing is that we reassign and refarm the spectrum. This is, for example, happening with the 700 megahertz as one example, which is always the best way that we go from one technology to another one, and that we try to optimize the use of those existing spectrum. And then one new scheme is that we prepare ourselves and the industry how we can open up ourselves for sharing methodologies. We have heard it already from Linda and from Pierre. I will also give you a brief example on the license shared access, which we consider is a rather simple exercise. And simple means, for example, to unlock the 2.3 gigahertz spectrum here in Europe and to utilize the economy of scale of the existing technologies already available in other regions. We talked a lot about high spectrum or higher spectrum. There is also this huge potential, which I call the gold mine for coverage and capacity, the UHF band, where we are all eager from the mobile broadband industry to get more access to it. So starting with the digital dividend, the 800 megahertz band, the 700 megahertz band coming. And we are also eager to see how could we come to a friendly coexistence or to a convergence between the broadcasters and the broadband community. And interestingly, that's what we see, that there's a huge interest from the broadcast industry to understand what is the characteristics and what LTE could do for their network, providing linear TV or utilizing that access. And I think this is one innovation which is not talking about, say, 30 gigahertz spectrum. This is talking about a very valuable spectrum where we need to engage into discussions how we can possibly build a system which provides services for both players. So that means, for example, that we can think about an integrated UHF multimedia network, which would allow that we can provide linear broadcast possibly in a more efficient way over a larger ecosystem, over an LTE network. Then coming back to the spectrum usage models. So the classical approach we have is that we have this mainstream approach that we auction cleared spectrum to an operator. And what are the benefits? This is an exclusive use, and it ensures for those who has the license that he can provide quality of service, so that he can also charge for it. So this approach will not go away. It will be the mainstream approach for the time to come. On the other side, we have already touched the unlicensed, which is the totally shared approach, where we have the usage and the integration of Wi-Fi technology. And just recently, there was opening up the playing field, and what I will also touch in a few minutes about the LTE and unlicensed band, which is pretty interesting because it opens up the competition, and it also shows that we can see, can we use a technology in order to utilize that real estate which is available for the purpose of the mobile broadband communication. For sure, it's a shared use, so that means it will provide a rather unpredictable quality of service. And then in the middle, there is the best of both worlds, or you can see, can we combine something from the left and something from the right? This is what is now known as licensed shared access, or you might have also heard the term authorized shared access, ASA. So this is that we have on an exclusive base, on a shared binary base, for example, in time, location, or frequency, that an incumbent, which could be a government, could be a defense organization, gives an exclusive license to a secondary holder, which could be a mobile network operator. And with this exclusive license, he would be able to provide a predictable quality of service. Unlicensed spectrum. So don't go into details of the graphs, but we know already that the majority of the traffic which is generated from cellular devices is going already over the Wi-Fi network, so that the smartphone connects to the Wi-Fi access points either in the business or at home. So that also means that Wi-Fi and those technologies will need more spectrum. And this is already what we see. So the 2.4 gigahertz band is pretty crowded. Wi-Fi with the variants 11AC and then the 11AX, which is coming. So the high efficiency wireless LAN will also go and populate the 5 gigahertz band. And we have the WiGig, which will come to utilize the 60 gigahertz band. So there's also plenty of space for exploring the unlicensed spectrum. And interestingly now, there is a competitor coming that could LTE also be deployed in unlicensed band. And this is something we can debate later on in the panel, if this is good or bad for the ecosystem, but it's some kind of competition which had always been healthy. It opens up a nice opportunity because it would provide an integrated approach, for example, for utilizing that spectrum for local area traffic offload. That's depicted here. So it started with this LTE for unlicensed band, but meanwhile, operators had been getting a bit cautious because they want to avoid, or we as the industry want to avoid, that if the regulators come across this topic and say, hey, you don't need licensed spectrum any longer. So therefore, the term which is now going to be used in various bodies is license-assisted access using LTE. What does that mean? So you always have an anchor system, which is the LTE over a licensed spectrum, which provides the uplink and downlink. And then you would aggregate, in addition, the unlicensed spectrum, for example, the 5 gigahertz band. So it's a unique combination of licensed and unlicensed band. The licensed band would provide the predictable QoS for handling the mobility, the signaling, the voice, and the data. And the unlicensed bands would be a supplementary downlink, or would be a carrier aggregation at the end, which provides this opportunistic use in order to boost the data rates. And keep in mind that typically in the networks, the asymmetry is that the downlink is, say, 5 to 10 times higher than the uplink. So that's a nice mechanism in order to foresee and support the traffic growth and to utilize this technology. So we have seen that the debate is now ongoing. There are challenges involved because we have to fulfill some specific band requirements. So we are talking about low amount of output power or only deployable indoors or eventually also outdoor. And we have different regional requirements, for example, to implement listen before talk technologies. Coming back to the LSA, only the small cake in the picture and the slide from Linda. So maybe it's more tasty if you have a delicious smaller cake before you get hungry for the other cake. Try to briefly explain what this LSA could be. So it's like a bit of a weather balloon that we need to understand what sharing could mean for us as an industry. It doesn't mean that it will be the mainstream in the long run, but we need to start small in order to grow. So what does it do? So it will unlock more spectrum with predictable QoS. So there needs to be a relationship between incumbent, which for example owns in France the 2.3 gigahertz band, and then there is an ASA LSA licensee, which could be a mobile network operator. So they enter an agreement which could be just a piece of paper where they say, okay, you are allowed to utilize this 2.3 gigahertz all over the time, but you're not allowed to use it at the Mediterranean Sea, and you're not allowed to use it here. That's it. No need for anything more complex. Just a piece of paper, a contract between the incumbent and the licensee. And then for sure, we're always eager as engineers to make it more complex and say, okay, we need a repository, we need an ASA controller. But things start simple. It could start with just an agreement on a piece of paper. And then that ASA licensee would be allowed to utilize this spectrum in France, except those exclusion zones, all over the time, and could provide that service to their customers. And what are the benefits for those, for the licensees? It means it would accelerate the spectrum harmonization, which is key, and it allows, for example, to utilize the LTE technologies, which is used elsewhere in the regions, like, for example, in India or in other, where the 2.3 gigahertz technology is just available. And it also brings an incentive for the incumbent because he can try to make some money out of this spectrum. So you need to find a win-win situation in order that both parties would enter such kind of collaboration. Now, this is a very complex picture, and I tried to decomplex it. So now a bit looking into this 2020 domain. We have a lot of discussions on spectrum above 6 gigahertz, so the 6 to 100, 6 to 300 gigahertz. And I recently heard a talk, and it was starting high hope, high risk. So we need to explore frequencies above 6 gigahertz. And I will try to tell you what happened, also what was triggered 1 year ago. You see here a map which a colleague of mine did. So different regions, different spectrum available. So this would be the centimeter waves up to 30 gigahertz. And this would be the huge amount of spectrum available for the millimeter waves. But we as an industry, we are eager to grab that one, but there are incumbents. And we need to understand what will this technology or what will this spectrum do for us. And this is something we have triggered and where we are moving a bit forward. But we need to do a lot more in order to see how can we unlock this spectrum, how can we utilize it, and at the end, how can we make some money out of it. Because we know the propagation conditions will be different. It will possibly be confined to small cell deployment. So then we need to see how that would come into the network deployment play I mentioned at the beginning. So 1 year ago, 20th of May 2013, Laurie showed this slide, still with a different logo there, and he proposed that we as an industry should work together and share our results to understand the characteristics of that spectrum. And I'm happy today that I can say, okay, yes, we moved forward. So 3 weeks ago, together with the Ted Rappaport from the New York University, we were hosting a technical conference where we had been pulling together a lot of experts, sharing the results, and I'm pleased that I can show you the draft conclusions, that you know, okay, we are moving forward, but we have not yet reached the final conclusion. So many thanks for all who participated in this event. I consider it as very successful and was also happy to see that there was willingness and openness to share the results. So let's go through. First good thing, there are no showstoppers identified. So there is hope for the millimeter wave because it's already a proven technology for the backhaul, and already the results show that there is a good likelihood that we can also make it useful for mobile access. Some very technical detailed conclusions I try to guide you through. So is that there had been a lot of parties there and companies showing the various channel measurements. And the channel measurements had been done for mainly the 28 to 100 gigahertz, so the millimeter wave band. And if you look into those path loss components, interestingly, it were rather similar as the lower frequency bands. So that was a good outcome and a very consistent approach, but no one was really saying, okay, yes, it's 2.0. So we need to conduct more studies for that. Important is that you, when you go for the millimeter wave band, that you take into account the modeling of the blockage. For example, if a lorry passes by the pedestrian in a street canyon, then what we have seen that reflections are rather similar as the lower frequency band, but you can't count on diffraction. So that's different compared to the classical frequencies. And then for sure, some critical persons always say rain and oxygen might be a problem, but if you talk about street canyon deployments or ultra-dense networks where we have inter-site distances of less than 200 meters, that has been found not to be a problem. One debate which was not finally concluded was that are millimeter wave systems noise or interference limited? So that's something where further work needs to be continued. And then also we had a discussion how to move forward, because this is all done in the research domain. So how can we move forward with the channel modeling? Should we take the more 3GPP-like approach, or do we need an even more complex model? And this is something to follow up. Also Nakamura-san was so kind to run the panel there, and he has taken together with 2 other colleagues an action item to debate and discuss how we can move this forward. Then also when we go for higher frequency bands, we know that the path loss might be a problem, but this is something we can overcome, as we have seen by application of a higher number of antennas at the same size, because the wavelength goes down. Common sense was, and this is also an action we need to continue forward as an ecosystem, that we need to share those results and we need to conduct more extensive measurements for that. Then coming back, remember this, we need to go for a complex process in order to unlock those bands at above 6 gigahertz. So we are eager to get access to this blue nice spectrum above there. So what do we need to do? Concrete actions. I like actions and facts and figures. So we need to work that the World Radio Conference 15 agrees an agenda item for 1819 to identify frequency bands for IMT. If we are not going to make that, then millimeter wave or above 6 gigahertz will be 6G. Or will not come, will come in the next World Radio Conference. Then we need to look, so in terms of the process, that we identify those bands, remember this colorful orange and yellow slide ahead, that they need to be allocated for mobile service. And the good news is that there are already a lot of allocations, either on a primary or on a co-primary basis. If we have done this, then the next step is that we need to identify those allocations for IMT. And the good news is, if there is already a mobile allocation, then we only need to put the footnote in some pieces of paper, which is a lengthy process in order to say, okay, this bands could be used for IMT. And then we discussed it also, and we touched it. We need to have this IMT process, which is well underway, as Magnus mentioned, with the requirements coming up, in order to have also this IMT stamp at the end of the day. I called it here that we need to build up this IMT federation, which includes the IMT 2000, the IMT-A, and then possibly this IMT 2020 or IMT 5G. And then important is that we are not limiting and say IMT 2020 is only allowed to access spectrum above 6 gigahertz. All IMT family members should be able to access all IMT bands below and above 6 gigahertz, because that opens up the flexibility that we could utilize LTE, for example, in spectrum above 6 gigahertz, or that we do some kind of scaling, as Nakamura-san mentioned. And then also, if we are smart enough defining one system, one fits all, that we are also able to deploy it in the spectrum bands below 3 gigahertz. That brings me to the conclusions, so some takeaways, also then as a discussion point for the panel. Exclusive spectrum is the preferred way for mobile broadband, as it provides predictable conditions. We need to go, when we discuss a spectrum, harmonization is key, because it brings economy of scale. It eases the border coordination and the international roaming. LSA is a weather balloon or a valuable tool in order to boost the spectrum optimization where exclusive use is not feasible. And keep in mind, beside those above 6 gigahertz, let's also don't forget the UHF band, which has a high potential that we can not go in a controversion or into a competition, but more into a convergence between broadcasters and broadband operators. And then, as just mentioned, we need to work on the World Radio Conference 15 on the agenda item. We need to identify that for mobile service, primary and co-primary. And then finally, we need to work a lot together in order to de-risk, I call it here, the new frontiers of centimeter and millimeter wave. So that's something we need to do pre-3GPP harmonization for the channel model, and we need to do a lot of homework to conclude that. With that, I'm at the end and ready for questions.
Okay. Thank you, Peter.